GL over 2. And then the D is 1/2 L. Uh, by 1/2 L. Wait. Uh, wait a minute. Oh.
Yeah, V, if I need to find V squared, basically. EK, and also is EK is 1/2 mv squared minus originally 0, right? When you start here, it's 0, right?
That's equals. GL.
I can definitely find my V squared anyway.
2. M cancel out. B squared equals G. GL.
Yep. So this is the big step number 1. Finding the work energy or conservation of energy.
And then find the tension.
Yes, and then find the. But then we focus on first. We focus on energy, and then we focus on circular motion, right?
Oh. Oh, now we can do the circular centripetal force.
Yeah.
So it'd be times over that's the tension.
What's this?
The tension?
Oh, you think the
it-
tension is just the centripetal force, right?
Oh, but then there's gravity too.
Yeah, there's a gravity component in that direction. You also need to think. So that's why I wrote last time in the end, I said F net
Yeah.
centripetal force direction equals to the F.
Mm-hmm.
So what's the component of gravity in that direction? This direction. You have to draw that graph carefully.
Wait, centripetal force pulls toward the center.
Yeah.
So that pulls towards the center, and that gravity still pulls down this way. Right? Gravity pulls it. Oh.
Yeah, he's opposed in that direction. Move it over.
We need to find gravity going this direction. Mm,
So let me draw this one. In here, I have to draw this one carefully, otherwise I can't really get it. This is the originally, and this is now. And this is the circular motion move. And this is my gravity. And so there is a XY coordinate thing, which is better to draw. This is one of the coordinate x's. This is the other one. Does that make sense? Because this is the tangent line, right? At this point.
mm-hmm.
And this is perpendicular to that tangent line is the radius, right? So I want to find out this rectangle. Let me get this. This is my mg. So I can find my theta in here is, let me get a better pen. My theta in here is 30 degree. Does that make sense?
Mm-hmm.
Well, I can prove it. This is a 30 degree, so equals to this one, right? And this one equals to this 30 degree. See, this at this part and this at this part, both 90 degrees. So this one must equals to that one, right? This is your 30 degree in here. So the 30, 30, and 30, actually this 30 and 30. Oh, hold on a second. Does that make sense? So I can find that one is 30. I don't have to show carefully. It's geometry problem. So, and then this one is mg. See, this is a rectangle, right? Technically, this is a big rectangle. So this one is the mg sine theta. Does that make sense? This part?
Yeah.
So now I can find that it's my t minus my mg sine theta, right?
Mm-hmm.
Does that make sense? This is called my f net in circular motion direction, right? And this provide for my m, well, centripetal force, right?
Mm-hmm.
Does that make sense?
Mm-hmm.
Okay. So I guess this drawing is kind of really important here, right? Is it making sense?
F net. F. Wait, is it T minus?
T minus mg sine theta, because this one is mg sine theta, right? Because in here this is t, and so the opposite direction is mg sine theta. So that's
So
why in
then
this
we
direction.
add mg sine theta to the tangent.
That's all the forces along that direction, right? There's only one other force, which is this component, but this component does nothing in this, because they're perpendicular, it does nothing in this direction. So I don't have to think about this component. Right? The perpendicular,
So
this
this is
does
a
nothing in there.
total. Wait, so this is a total, then we add mg sine theta.
Mm.
And then that's the tension. Right?
Yeah. Wait, what's this then?
That's F centripetal net. F net C.
Oh, sure. So what's the result finally for the, what's the tension?
It's this root m squared g l over l plus mg sine theta.
Wait,
Wait,
in the end, it's an easy result. I mean, after all the calculation, of course.
Wait.
So this is just basically this one is 1/2 mg, right?
Yeah.
And since your v square is gl, this is l, right? So m gl over l. So this is mg, right?
Mm-hmm.
So basically
Oh,
it's
and
a
I can't. And
3/2 mg, right? T. Does that make
yeah,
sense?
yeah,
Is it the same thing as yours?
yeah.
After calculation, it's 3 ohms, 1.5 mg. Oh, okay.
Okay.
Yeah, with the technology that we have, we can actually find that tension at that moment because you can change something. You can change this string into a spring, which actually can tells you the actual force in that spring. So you can definitely check that, right?
Mhm.
So what's the like tension in each second in all moment in every moment. Is this one okay?
Mm-hmm.
What should we remember about this? This is probably the most complicated question so far.
The gravity component.
Yeah, gravity component. Which is gravity component, which is this second step, which is the F net centripetal force direction, right? You have to think about the FG centripetal force component. And that drawing how to be careful. And also the work energy principle, right? You can do it separately. B.
To the block immediately after the collision. If the collision's elastic, that means it. Okay. So that means mv equals and momentum is conserved, so it's 4 v. And then v at here, 1/2 v squared equals mgl. We get rid of v equals
Yep.
to v equals square root of 2 gl. And then root 2 equals v and cancel out again. So v equals 2 gl over 4. Right?
So this is the velocity at that moment before the collision, right?
Yeah. Oh, isn't um oh, isn't it step formula?
So this is before the collision, which means after that. This is the period number 1, which is very nice. But you have to think about a period number 2, which is the collision, right?
Yeah.
What's happening in collisions? What principle that we should use?
Um, the the momentum is conserved and all that. Oh, if the energy is conserved, that means that means 2 mv. It has to equal. It has to equal mgl, right? For the energy to be
you're
conserved.
using 1/2
Yeah.
m times this g is 2gl, right? So using
Yeah.
this, then it's gl, right? mgl, right?
Yeah.
This is the energy before the collision, right?
Yeah.
Okay.
And then after the collision has to be the same energy, right? Because it's
Yes,
conserved.
but totally it would be the same energy.
Okay, so then we can cancel this out too. So the velocity then would be v equals should be mg.
Wait. That's it equals to the energy after, but the energy after is splitting into 2 parts.
Oh.
One is the little ball, the other one is the block.
Oh.
They both have the energy. They split that.
That's m1v1 plus m2v2 equals oh wait. Oh, I'm silly. This is oh. Oh, okay. So
Are you using momentum conservation?
yeah.
Yeah, that too. Actually, you're not silly. You need both for this question. Only one of them can't really crack.
Oh, you need both to have
Yeah,
momentum.
this one is complicated. We need both. Because in there you see that you have v1 and v2. You have 2 variables. You can't really do with one equation. You need that energy conservation too. So you have 2 variables and 2 equations. Does that make sense?
Okay. Wait, one. Okay. So then I found the 1/2. 1/2 times 4. 1/2 4 at v squared. For it to have the same energy would be 2 over 2. Is it right? Immediately after the collision. Yeah, the box immediately after the collision. Total energy. Wait, so MGL is the energy of the ball before it hits the block, right?
Yeah.
And then when it hits the ball with that energy, that means
It split the energy in 2 parts.
oh, so it'd be
Yeah, I should have probably marked after the collision. You can probably imagine this one is probably in that direction.
yeah.
Even if I'm wrong, it's could be negative, and it's okay anyway.
Oh, so we need to find the part that's going that way.
And then there's a v2 in here.
V1 and V2. And then the energy. Wait.
So would it be just m v1? Let's say I don't really know positive or negative. Let's pretend we don't know. Actually, we don't know. Plus, well, 4m, right? Time v2, right? Must equals to the before, which is m, because before the momentum is 0, right? So m times the square root 2gl, right? Here, right? This is equation 1 about conservation of momentum, right? Is that making sense?
Mm-hmm.
And the second one is your mgv square, which is mgl, right?
Yeah.
And this totally before energy equals the energy after 1/2 mv1 squared plus 1/2 m4 mv2 squared. Right?
Okay.
Which is a little tricky, this one. So this is simultaneous equation then, right?
Yeah. Oh.
Which one is easier? You probably should use substitution or something, right?
Yeah. Wait.
Yeah, at this moment, I prefer I'm like a physics teacher, not a math teacher. I like physics now. I have to solve it. It's also not that easy. So m and m and m. So v1 is probably not that difficult to get it, right? v1 equals to 2 square root 2gl minus 4v2, right? I probably can substitute it in the second one, right? So this gl, so so gl equals to 1/2. Maybe there's other better like a method. Just square root 2 minus 4v squaring and plus 4v2. Well, actually not 4v2 because this is 2, so this is 2. 4 times 1/2. So v2 squared. Let's not make a mistake here. Scary mistakes here. Oh, actually I did make a mistake here. Let me think. And this is GL 1/2. No, I'm okay. Yeah. So this is the case, right? Because there's a 1/2, it's really annoying. So let me time 2. This doesn't really have. So there's a 4 here, right? It is okay. So I can, well, I have to expand that probably, right? 2gl plus 16v2 squared minus 8 v2 square root 2gl, right? Does that make sense? And we have what? We have a 4 plus a 4v2 squared. So this is a 20, right? 20 v2 squared, right? I have 20 v2 squared. And I have a, this 2gl and this 2gl is out, right? So then this 420 minus, oh, this is good. There's only 8 V2 square root 2GL, right?
Mm-hmm.
And V2 because V2 can't be 0, right? We don't want to, is V2 can be 0? Now, I don't think V2 can be 0 here, right? So V2 can't be 0, so I can simplify it. So now I can find V2. It's just divided by 4, which means 2 and over 5. Right? And the square root 2GL, right?
Mm-hmm.
Yeah. Yeah, so that's the V2, right? Does that make sense?
Mm-hmm.
Let's see whether it answered the question B. Split speed of the block. Oh, I think it's just this one, right? This is answering this. You're not asking V1, so we don't have to do V1, right? Does that make sense?
Yeah.
So this is a, well, a little complicated calculation. Equation not that easy. So substitution I have to use, and I would expand that big square thing. Is B okay?
Yeah.
So again, so the big step is energy conservation, one equation, right? And
Yeah.
momentum conservation, another equation. And you have to use substitution and everything, right? To solve the simultaneous equation. Carefully and slowly, otherwise very well, I said we don't have to find V1, but we have to do C, right? I don't want to split. I don't want to erase anything in case I forget. Just that a little bit there. Okay, how about C? To what height H will the ball rebound after the collision? Oh, now we know V1 must go to the left, right? You want to say it's rebound, right?
So V1. It's V1 back, then it's the. This is a circular motion.
Yeah, what's the V1?
Well, we already found V1, right? It's this.
Well, we find V2 actually.
Oh, so then
Crazy calculation. Better find V1.
V1 is MGL minus V2, right? Wait.
Yeah, you can use this one, right?
Yeah.
It's 2GL equals to V1 plus 2V2.
Uh-huh.
Ah, great calculation. 2GL minus 4 times V2. V2 is in here. I guess it's 8 over 5, right? Square root 2GL. Let me get it.
Yeah.
So this is V1. And then what's the height?
Height. Uh, um,
What height will the ball rebound after the collision?
a squared over. Wait. Squared over. Wait. You need to find the angle.
We can, but that'd be more complicated method. If you want to find angle, are you trying to use circular motion?
Wait, if
Oh, you can find angle. But he didn't ask us to find angle. You can use energy.
oh,
Just the
energy.
height. Just the height.
Oh, just the
Yeah.
oh.
You can find the height and then you can find the angle. But we
No.
didn't ask us angle. We can just find the height.
H. If you want to find H, then M cancel out. 1/2 V1 squared over G. Well, V1 over 2G equals to H. And then you just plug that one in.
Yeah, that's crazy calculation.
Yeah.
I never did it, but maybe ChatGPT can do the whole thing for us. I don't really know.
Yeah.
We can substitute all the equation and then ask him to do it, right?
Yeah.
You understand that, right?
Yeah.
Wait.
Yeah.
So anyway, this method can definitely help us, but I think that you should better redo this question after the class. Actually, you should
Okay.
redo all the questions that we did together, doing together and doing by yourself, two different things, and you get to experience more when you do yourself. So this is C is okay, right? This equation definitely can help us to find the reband height, right? We don't have find angle, right? You actually can find angle. You get the height, you can get the angle eventually, right?
Yeah.
But he didn't ask, so we don't. And let's do, well, of course, the homework is this two questions, and also including that the new
Okay.
circular motion and the
Yeah.
gravitational
Yeah.
force thing, right?
Yeah.
And this, let's see whether we have time to finish this one. Probably the first question. You can read too.
Wait, measure the muzzle speed of the block. Suspend perfectly inelastic block swings upward. Consider a bullet M with velocity V as it enters the block of the cord. In the terms of mg and y, determine the speed v of the bullet. If it's perfectly inelastic, that means the energy isn't conserved. But the
Yeah.
momentum is the same. E
But
equals
the good thing they have a common velocity after collision. Yeah.
so it's Vm plus m. Wait. So after it's m plus with common velocity v1 after, so that equals to v2
Yeah.
plus v, but then it's still before, so this is 0.
Yeah.
So this is 0, so mv equals m plus m times v1. And v1
It's after. We probably should use v prime kind of thing. After the class, we normally use a prime, just in case we make it's difficult to make a difference.
but we can't have v prime, so
Yeah, then we can have v prime.
v prime
It's
equals
mv over m plus m, right?
yeah.
Hmm.
Well, it says determine the speed of the bullet, so oh, so then we divide that by m, and then we add v, but then we have to put v prime in. Oh, so then we can just put that there, right? And then that cancels out. And then if we put that there, then the m plus m cancels out, and then the mv and v m. Oh wait, that would be the same thing. Wait. It says mg and y. G and y. E and y.
You want to use y, which is making us a crazy thing. I can give you a hint, and you can do it because I kind of have another class now. The thing you have to be careful is using energy. After this one, this is good. Good step one. Step
Okay.
2 is using energy.
Okay.
The energy is now you have well, you basically have a m plus m, at the big mass, and time gy potential energy, right? This is
Yeah.
all the energy you have because you don't have kinetic energy before, after. And then before it only have kinetic energy, right?
Mm-hmm.
V prime squared. So using this one and this one together, you can answer A. Does that make sense?
Yeah. Yeah.
Yeah, I kind of have to sing out now. So, well, just really do this 2 question and also
Okay.
the other homework.
Okay.
Have a good weekend. God bless you.
You too.